Let's start by learning to solve systems of equations by graphing. Get your graph paper and rulers ready. No squiggly lines allowed here. A system of equations is when you have two or more equations using the same variables. For example, let's say you're using 2x plus y equals 20 and x minus 3y equals 15. This would be considered a system of equations because we are using two variables that are the same. We're using both x and y. I can have more equations to make up a system of equations, but generally it is only two equations, maybe three or four. The solution to the system is the point that satisfies all of the equation. This point will be an ordered pair. Remember, it'll be an x and a y. Now later we'll learn about equations that have more variables, and you'll have to have an ordered pair that is x, y, and z, or all of the variables that are included in the system. When you are graphing, which is the method that we're going to learn in this lesson, you will encounter three different possibilities. The three possible situations that you will encounter when you are graphing are intersecting lines. You'll have lines that look just like this. When you come across lines that are intersecting, the solution is the solution that they share. So the point where the lines intersect is your solution. So look at these two lines. The point right there in the middle where they intersect, right here, that is the solution that those two lines have in common. In this case, that solution is the point 1, 2. That is the point where x is 1 and y is 2. Remember, an ordered pair is x, comma, y. The second situation is when you have parallel lines. The lines won't cross at all. In other words, they don't share any points at all. Never intersect. Since the lines never cross, we say that there is no solution. Remember, parallel lines have the same slope and different y-intercepts. The last situation that you will come across are coinciding lines, and those lines are lines that lie one right on top of the other, and they share all points. In other words, they have the same slope, and coinciding, they lie right on top of one another, and they have infinitely many solutions. They will go through the y-axis at the same point, and their slopes change at the same rate. So what is the solution of the system that's graphed here? Where do these two lines cross? Well, if we take a look, we can see that it intersects at this point right here. The point of intersection for this system of equations is the point 2, negative 2. So the solution for this system of equations is the point 2, negative 2. So at the point x, y, where x equals 2 and y equals negative 2, that is the point that those two equations share. So let's solve a system of equations by graphing. The items that you'll need are graph paper and a ruler or a straight edge. Remember, we are looking for exact points. We want exact points, and the only way you can get those is if you use a straight edge and graph paper. If you use those, you will have a very happy Mrs. Dodson. And we always want a very happy Mrs. Dodson, because we all know if Mrs. Dodson's happy, everybody's happy. So let's find the solution to the following system. 2x plus y equals 4 and x minus y equals 2. They both have the same variables, x and y, and we want to see what point they share on a graph. Now remember, we learned several ways to graph equations. We can use x and y intercepts, or we can use y equals mx plus. In this case, I am using the x and y intercepts. Remember, to use the x and y intercepts, all we have to do are plug in zeros and solve for the remaining variable. If we graph those ordered pairs, we can find out where these two lines cross and determine if they share a point. Remember, they're going to share 1 point, no points, or an infinite number of points. So if I graph those two equations, or graph using the ordered pairs, I want to plot, for the first equation, I want to plot the point 0, 4 and the point 2, 0 and connect them lines. So that's what those two lines will look like. And I look for the point where they cross. In this case, they're going to cross right here at this point. So what is the solution for this system of equations? You're essentially asking yourself where they intersect. So these two lines intersect right here. They intersect at the point 2, 0. So that is the solution for this system of equations. That is the only point that they have in common. The last step is to that point, that ordered pair of 2, 0 works for both systems, or for both equations in the system. Remember, we practiced testing a point to make sure it was a solution for both equations. So, how do we do that? We just take each coordinate of the ordered pair and plug it into both equations and see if it works. So let's plug it into the first equation. Let's plug it into 2x plus y equals 4 and see if it gives us a true solution. So plugging 2 in for x and 0 in for y, do we get an answer of 4? Remember, we want to see if it gives us this result. Yes, it does. 2 times 2 is 4 plus 0. That does give us 4. And now let's plug it into the second equation and see if it works. Plug 2 in for x and 0 in for y again. Yes, that works as well. So our ordered pair that we found of 2, 0, where these lines cross, is an actual solution to this system equation. So let's try another one. Let's find the solution to this system of equations. Y equals 2x minus 3 and negative 2x plus y equals 1. This time, let's use y equals mx plus b form, just so I can show you can use either method to graph, whichever one you like. You know I prefer y equals mx plus b for everything, so I'm going to use that one. Before I can use that, put both equations in y equals mx plus b form. This graph, or this equation, is already in y equals mx plus b form, so I don't need to do anything with that one. All the work's done there. But this one, I need to do a little rearranging. I need to bring this 2x over and insert it right in there. That's no big deal. I just need to add it to both sides. So if I add the 2x to both sides, I just take y equals, I add 2x plus 2x, and I'm inserting it over here, positive 2x. And remember that 2x has a special spot to sit when it's in y equals mx plus b form. It needs to sit immediately after the equal sign. So I'm going to bump it in there in front of the 1. And the 1 is positive, so it's going to go right there. So here is this equation in y equals mx plus b form. And now I'm ready to go. I'm ready to graph. So now that I've got them in y equals mx plus b form, paper out and your ruler. In your first equation, your slope is 2. Remember, it's sitting right here. M is 2. So your rise over run in this equation is 2 over 1. Your y-intercept is negative 3. That's your starting point. In your second equation, your slope is 2 over 1. Uh-oh, I think I see what's going to happen here. And your starting point is 1. When I graph these two equations, look what happened. I had the same slope, so they're parallel lines. They're never going to touch. That means they don't have a solution. They don't share any points. When the lines don't intersect, there is no solution. Remember, the whole point is looking for the common point. If there is no common point, then there is no shared solution. So we say there's no solution. If you're graphing and you switch your equations into y equals mx plus b form, and you see, like I did, that they have the same slope, you don't even have to graph them. unless of course I tell you to graph them because I want to see that you can graph. But if all I'm asking you to do is tell me how many solutions they have, if you notice that they have the same slope, then you don't even need to go on and graph them. You can say these have no solution because they have the same slope, as long as their y-intercept is different. Check your answer. Well, there's no solution, so there's not a lot to check. Just make sure that you set your equations up correctly. Double check your work. I double checked it, and I did it right. So nothing left to do there. What's the solution of this system? Use your ruler and your graph paper to determine the solution to this one. Pause the lesson and see if you can determine the correct solution. Restart the lesson and then check your result. Well, how did you do? Once you put them in y equals mx plus b form, you should have gotten y equals 3x minus 8. And for the second equation, you should have also gotten y equals 3x minus 8. And you might have at first thought, well, they've got the same slope, they're parallel, but they've also got the same y-intercept. So that means they're going to cross at the same y-intercept. So the lines are exactly the same. And two lines that are exactly the same share all the same points. And lines that share all the same points have infinitely many solutions. So now you know how to solve a system of equations using a graph. Let's just summarize. Step 1. Graph both equations. Decide whether you're going to use y equals mx plus b or x and y intercepts. I prefer y equals mx plus b because that way you can see right away if you have the same slope, you're going to have no solution. If you have the same slope and the same y-intercept, you're going to have coinciding lines. Step 2. Look to see if the graphs intersect. This tells you the solution. If you didn't identify using the slope and y-intercept in step 1, then you're looking at the graph. So you're looking for either parallel lines, intersecting lines, or all the same line, one on top of the other. Check your solution. If you find a single solution, plug it back into both equations and make sure you've got the right one. And above all, use a ruler and graph paper because you can't estimate a solution from a sketched graph. It's just impossible.